Greetings folks, my name is John Gabriel and this is the new Calculus channel. So today I'm going to be talking about another discussion on sci.math, again involving my historic geometric theorem of January 2020. So let's begin. Now in this thread I've constantly pointed to a link to my article, this article here, and it's pretty obvious that not only do mainstream academics not read it, but they don't have any interest in understanding. And I'll tell you why, because there's this contributor here called Kony who asks me in this thread, how do you know that the derivative is equal to 2x and that the difference, which is q of x comma h, is equal to h? Why not f of x is equal to x and that is equal to x plus h? So, well, if he had bothered studying my article, he would have found out. And of course, a lot of you are not going to know what I'm talking about unless you actually read this article, to which I will place a link in the details section. So, now, how do we know that f prime of x and q of x h are respectively equal to f1 over h and f2 over h? Okay, and how do we know that only f2 over h contains an expression in x and f1 over h is x plus h? So in my document here I tell you why, and one of the reasons is this. So you see, if you're looking at this, I should actually just move this out of the way. If you're looking at this diagram here, the slope of the tangent line does not depend on h. Okay, how do I know that? Well, you might say, well, look at it. It's f2 divided by h, but that doesn't matter because I can take any similar triangle. See, and that's got nothing to do with h. That will give me the same slope. Do you see that? That does not depend on h. However, the slope of the secant line, this red line, depends on both. Okay, it depends on x, the value of the point of tangency, as well as h. Okay, so if I had to extend this line here to the red secant line, then you would see that it depends on both x and h, because in order to get the point on this line here, you need the x-coordinate of this point plus h. But that's not the case with the tangent line. You don't need to. This point here only needs the x, okay? And you can choose any h that you like here. It doesn't matter, right? So it doesn't depend on a particular h. Whereas this here depends on h, all right? You see that, the secant line? Okay, so that's all I wanted to show you. I am not going to ramble on and on. I encourage you to read this article of mine, this article here, which is called the General Derivative Formula. It's historic, and it's very important because it exposes the fraudulent formulation of mainstream calculus. Now notice when I say that, I don't mean that the results of calculus are wrong. On the contrary, I'm saying the formulation is wrong. In other words, the use of limit theory, infinity, and infinitesimals actually have nothing to do with calculating areas and volumes and surface areas and flow integrals and line integrals and all those good things. All that rubbish can be left out very nicely because it's explained geometrically. Okay, so and that's what this theorem does. So, for example, there's no need to learn limit theory or real analysis, okay, or anything like that. And of course, Cauchy was wrong because he said that one would not be able to define the derivative by any means other than algebra. That's complete garbage. That's what I show you in my document is untrue. You can learn calculus just with high school geometry and trigonometry and algebra, okay? There's no need to learn many differentiation rules and techniques. This one formula works on any function, this formula here, and it's proved in my theorem. Okay, my theorem is explained in this file. in this article. Very well then, I'll leave you with that. My name is John Gabriel. This is a New Calculus channel. Stay safe. Till next time, goodbye.